I think we need to continue exploring the duality of artificial intelligence, and minimize the bad and maximize the good. We have this kind of almost priesthood sense towards AI at this point that I don't think is healthy, and that we need to get as many people that are that understand the development and safe application of these systems, and we'll be a lot better for it as we move from AI being something that sits up on a pedestal to something that's just laced through every other field of research and engineering. We're going to see a great flourishing of society, and it's on us to make sure that that's a correct statement.
Thank you for joining Change I Am Possible, which is India's first feature tech podcast. And today I'm really happy and delighted to have Mr. Mc Gregor, who is a machine learning architect at Syntiant. He is also developing the partnership on AI's incident database and is working with the XPRIZE Foundation to structure the IBM Watson AI XPRIZE, a $5 million contest for solving grand challenges with artificial intelligence. His technical work spans neural accelerators for energy-efficient inference, deep learning for speech and heliophysics, and reinforcement learning for wildfire suppression for policy. Sean, it's a pleasure and honor to have you on Change I Am Possible podcast. Thank you for taking time and being part of this conversation. So really excited for this. So you are part of 3 excellent companies, each creating and accelerating artificial intelligence. So can you start with giving a brief intro and your roles in these 3 separate organizations?
First, thank you for having me on today, and sharing the company of all the other auspicious people that you've had on your podcast. And I guess to start off with, the kind of day job, so to speak, is with the Syntiant Corporation, and we are motivated by making energy-efficient neural network processors. So there's this big problem in neural networks at this point that which are really good at understanding the unstructured world, images, audio, and the like, where most of the solutions are very energy intensive. So if you want to move a neural network out of the cloud, out of the data center into the real world, you have to really solve that energy intensity problem. And this is also a fundamental problem in machine learning and artificial intelligence in general, where we can do a great many things by just pouring energy, pouring effort into it. You can do a lot of smart things if you do a lot of dumb things incredibly fast. And what we have to do is get a lot smarter about it, and part of that is making our silicon architectures a lot more energy efficient, which is what I do at Syntiant, which is building the machine learning systems around our excellent hardware team's work, where they make it so that you have like no overhead in the course of computing a neural network. It's just computing a neural network, doing it efficiently, and my job is to build a lot of the infrastructure surrounding the chip so that you're able to train and ship a model and put it onto things like selling cell phones and hearing aids and other things that really don't have a big battery, much less a nuclear reactor that flows into the nearby data center. Shortly before starting in Syntiant, I started as a lead technical consultant on the IBM Watson AI XPRIZE, which is, I guess first to set off what is XPRIZE, is a grand challenge science and technology organization. Basically, it's built around incentivizing moonshots. In fact, one of the prizes was a literal moonshot, and that was the Google Lunar XPRIZE. My prize, though, which I've worked on almost exclusively, has been the essentially a prize in AI for good. So the teams weren't charged with going to the moon. They were told, you need to do good and you need to use AI. It was a challenge agnostic and technology specific prize, in contrast to most of XPRIZE's prizes, which are challenge specific and technology agnostic, and you can use any technology. In that, I've had a very interesting time bringing together a lot of the judging modalities and working to make it so the teams can be successful through this multi-year prizes. They're competing for $5 million. And we actually just recently announced the 3 finalists in the prize, which is quite exciting. So people should watch out for the finals of that, which is going to be available online, and we hope people will participate in the finals to the degree they're able to from home. And that has been really an enlightening venue for a lot of my work coming from grad school, which was motivating questions on like what is for good and how do you ensure that AI is benefiting people and society. And that's where I came to collaborate with the Partnership on AI right around the founding of this organization, which is a collection of the world's largest tech companies and civil society organizations. So as part of that work, and a thing that's been a lot of my drive with the Partnership on AI has been developing a thing called the incident database, or the AI incident database, which is a collection of really bad things that have happened as a result of AI in the world. I myself am an optimist. I believe that AI can solve a great many of the problems in the world, but at the same time, we need to record, analyze, adapt, and mitigate these potential problems, because anytime you are making a computer system make decisions in the world, and anytime it gets away from the person who originally created it and someone else is putting it into the world, you need to record the failures just as we record when a plane crashes, and then learn from that plane crash to say, like, okay, never again. And we've seen through the last 50 years that air travel has become exponentially safer as compared to when the jet age first started. So yeah, sorry if that was a bit long-winded, but that's kind of the 3 pillars of the moment and where I'm sitting.
Lovely. How cool is that, Sean? Really, thank you for sharing your journey. And I've had a conversation with a few people vested in the space, and most of them are really in awe of the technology and don't understand that, we are sitting on a double-edged sword. It could go either way, and the choice really depends upon us, whatever you described is super awesome, with all the different companies, right from Syntiant to building energy efficient chips to XPRIZE, sorting out and shaping those startups who are building like great companies which can solve these humongous problems that's facing mankind, and you being one of those guys, I've been trying to pass out the greatness from there. It's how cool is that, and then the partnerships on AI, where you kind of understand that how important it is building a community, because I think artificial intelligence is one of the most scariest as one is the most awesome technology that mankind has ever seen, right? And it can go either way, and it really depends.
And it can go both ways.
Yes, exactly. So it is so very important for us to tread this path carefully and build a community where we engage everyone and nobody is left out, because what we build today will create a future, and not many people are paying attention. Yes, we are now pulling up these tech behemoths because only because that suddenly nations have understood that these tech companies are growing more powerful than nations, and suddenly they're going. Possibly, I mean, if you so there is a conversation which somehow I don't think there's any tech company, or any founder who starts with, okay, let's build something which is for bad. They have that whenever you start a company, your desire and intent is to create something good, but somehow technology, when it starts growing, it starts, it has the potential to completely go out of hand. So right now, when it comes to artificial intelligence, there is so much hype which is being created by the media. There's this fiction narrative which is being created by the media, and we all buy into it, and there is there's obviously the facts. So as somebody who's vested in the space, could you paint out the facts versus the fiction, and what also scares you of artificial intelligence and excites you of artificial intelligence?
Sure. I think the fiction that I'm most eager to dispel is the notion of AI today has some level of agency that arises above people, and that when AI goes wrong, it's like the AI system's responsibility. Most of the time, it should be tied more appropriately to a person or an organization, that it's not just something that arises out of the machine where that machine had agency and doing the bad thing. It's a human constructed thing at this point. It's not something that the AI is building itself and then that produces a runaway system that then produces a unusual outcome. So that's the first point I want to make there. The scariest thing to me is some computer program that is completely separated and can't even be attributed back to a person or organization. And really, we have a word for that that isn't AI and the computer systems world. It's a virus. It's a computer virus. And we are going to see increasingly adaptive computer viruses and things that are just moving through what is a really poorly protected system of infrastructure without any motive assigned to people. Just that is my primary concern when it comes to our what's called cyber physical infrastructure. Or as someone that has been engaged in optimization and in my current and past lives in various forms, I just have a unreasonable expectation, I think, that things be efficient and that people in our systems are trending towards that efficiency and that we don't have the level of waste that we have today. And the nice thing about AI is it's really decreasing the cost of doing intelligent things and avoiding the waste of resources, the waste of people's times. We can have such a flourishing of humanity if we are able to navigate this transition to offloading more and more of our work onto computer systems. I hope that we're able to navigate that socially. Like, there's a great amount of concern for the future of work. What does work look like as we lose more and more of what are the current jobs today? But that transition is scary. Like, I get that, but if we make that transition properly, it's a good thing that a lot of the jobs that don't require, like the thought, the whole human self to be invested in it, don't actually need to happen if people are then able to devote themselves to the things that they find themselves to be more creative and more thoughtful in of themselves. So I'm really hopeful for the future, but there are two different poles, and we could land at one or the other or both simultaneously. And I really want to emphasize how important it is to move towards that better outcome for everyone.
Right. You said that, these systems are getting more efficient and eventually we'll be offloading more and more work on these computer systems, artificial intelligence. Now, obviously, it comes with its pros and cons. Because of the pandemic today, we have actually transitioned towards that, unknowingly, because suddenly the entire emerging technology is being, looked at a lens which is more we are now talking about digital transformation, how emerging technologies could create impact, could benefit enterprise and how the way we kind of work and stuff like that. And then obviously, because of the social distancing, most of the companies right now are looking at automation, and then we've just started on this path. And eventually, I guess, when machines will become more and more efficient in the coming few years, a decade, yes, I do see that the larger workforce will start getting redundant. Whether that's a good thing or bad thing, I think it's a narrative that the government and the entire community and the world needs to come together and kind of address, because there is, if you see, we thrive on purpose, and purpose work gives us purpose. Now, is the world great where we only do creative things? It is debatable, and that then I'm sure we can go on forever. But I since I've been vested in the space, I do understand that how this growth of technology seems to be, I'm using the word inevitable, but it is inevitable, and that path will lead towards more automation. It will lead towards more job loss. It will lead towards a drastic shift in a society. Now, how do we handle that together and say, not let the people who are less privileged, hold them and have maybe like a universal basic income or something that supports families and people, will create a better world. So I think we need to come together and definitely address this monster which is being unleashed upon us. I use the term monster because technology is growing. It can transform mankind, but things like this, if we don't have a common consensus or a framework on how do we address job loss and massive job loss, which I don't think we are addressing. We're talking about it, but I don't see anybody addressing it. Not the government, not the people. Not what are your views on something like that? A future where machines are getting more and more intelligent, automation is leaving us jobless. I mean, how do we solve that problem?
So for this, I think it's important we first look to the past and then we can look to the future. And I think a good example of this is I attended at one point I actually got my PhD at a university that was formerly named an agricultural college. It was established to train people how to develop the land. Most people in the region were farmers, and by the time I got there, it was no longer called an agricultural college. It's a land grant university still, which is a special term in the United States for here's your land, develop it. But it's a land grant, sea grant, space grant, all these other things layered on top. And while there's still people that I knew that were like studying soil science and all those agricultural elements, that was really the minority of the university at this point. And when they go out into the world and they start doing soil samples and checking their properties, there's not that many people that are tilling that land. There's going to be a robot, effectively, like those tractors. They're robots. They're just going back and forth in the U.S. and there might be a person in there that hit a button to start the program, and that's about it. So you've gone from a period of time in the U.S. when the majority of people were farmers or farm-aligned. That's where all the wealth. And if you had told them that there's going to be this tractor and there's going to be this integrated logistical system where each stage that formerly involved 30 people is going to involve one person or fewer than one on average, they would be very concerned. They would be very scared. And what happened in the U.S., and I think that India is likely going through a similar transition at this point, is people moved into other jobs. People started working on other things. You have people that went from farming to industry, and then at that point, when you have people gathered in cities, you also have an easier time of going up the educational ladder and shifting into other work. where we go from there to today, though, and where um, things are scary now, and where AI is potentially scary is, let's just take one industry, autonomous driving. If autonomous driving is solved in a big way, in the course of 10 years, you're going to have many millions of jobs eliminated potentially overnight, because you'll have cars that can do that work very suddenly. So the speed at which it happens is scary. It's not that you have a century of transition from predominantly agricultural to industrial economy. It's that it could potentially happen overnight. And I think that every potential job that would happen to is going to be a different story. And we know that at the end of that, we're better off. Like if the people that are currently driving move into another line of work that is currently underserved, or doesn't have enough people doing it, then that's better for everyone. We get more of that other thing. So it's really about the time to transition that we need to think about. And the theory in the U.S. at least is that you try and retrain people, which isn't a great answer for them, unfortunately, because people have a lot of pride in their work. Like you do get to be a very skillful trucker that can really back the trailer in complicated ways. It's very impressive. And to be told you don't need to be doing that anymore, and that you should retrain to do this completely other thing, it's hard. So short term, I don't have an easy answer. Long term, I think that we need to figure out a way to get there, because as a species, we're far better off when we do that.
Right. Yeah. So I completely agree with you, Sean, when you say that we are better off with technology because it will play a huge role in an evolution, and it will take us to the next step. But again, I do not agree, because I mean, unlike the example you gave me of whether it's the industrial revolution or agricultural revolution, it hit one specific sector. Somehow we are in this exponential.
It was the biggest sector, though.
But once we have an intelligent machine, what job is safe? So there is, it will hit across, whether you're a teacher, whether you are a musician, it's going to eventually even create, there is already artificial intelligence agents which are creating music, it can do a basic video editing and stuff like that. And these are, narrow AI machines, but eventually, I guess, which we humans, as scientists, as a researcher, we thrive on purpose, and a purpose is to create better. So we are hung up on creating better and better and better. And in that creating better, what I feel, I mean, I could be completely wrong. So I feel that it's not going to be one specific sector. It's not just going to be like drivers are going to be eliminated because of autonomous, cars coming in, but it's going to be across. And I don't think we have a meaningful answer to that huge problem. Now you are heading the IBM Watson AI Prize, and I believe there were somewhere around 700 applications, for this thing. So how difficult or painful was it to do the shortlist, the semi-final shortlist, and also talk about some of the most promising startups and the solutions?
We've had teams that have worked on really every conceivable problem, and some that I never would have thought of in beekeeping. Putting sensors into beehives and then detecting on the basis of the vibrations and temperatures and things of the hive what the health of the hive is, like what's happening with the queen, to earthquake prediction. Other ones pertaining to resources and like efficient logistics around disasters. But coming now to the three final teams. First one is AI Fred, and they're actually in medicine, specifically mental health. And one of the problems that you have in mental health medication is it's a very tricky thing figuring out what medications are going to work for someone. And you often go through this cycle where you're trying one after another, and you have to use that medication for months at a time, sometimes before you figure out, does this medication work for you? And I think you typically figure out which medication is the right one for you around like the second or third try, or at least at that point, you know which one's better or worse than the others after you've cycled through them. And that's a kind of misery-inducing thing for people, because if you're getting medicated for mental health issues, you're probably not very happy until it starts working. So if you're able to cut down that by months, or even just cut straight to the most effective one and find one that you weren't going to find initially, then you're happier, you're more productive in society. Everyone is really benefiting. So that's AI for health. The next one is Marinus Analytics, and this one really shows the kind of dual use of technology, where technology can be used for evil and good, because they actually do a lot of like image biometrics, and basically detecting people and images to find them as they've been sex trafficked. So they'll identify a person that's maybe gone missing some years prior by scraping, like the darkest corners of the internet, and then highlighting, hey, we found her, and we need to rescue her. And so they've built a lot of tools around solving that problem, and bringing people out of really bad situations. The final one is Zap Malaria, and I think that most people don't need to be told that infectious diseases are bad, particularly over the last year. In this case, Zap Malaria is working on mosquito abatement, and making it so that when you have a place where a lot of the malaria vector mosquitoes are present, you can more effectively find where the stagnant water is that the mosquitoes are breeding in from satellite photography. So you can identify on a map, like, oh, there's this many hectares of exposed stagnant water here and over there, and then also additionally doing the planning and operational work for a mosquito abatement district, or whatever it is in the country it's being applied.
All three seem super exciting. So very excited about it. And I really believe that these hackathons and these prizes are a great way to source talent, because in the last few decades, and thanks to the internet, it has somehow kind of democratized knowledge, I mean, and it's given everybody an opportunity to kind of, the geography does not matter. You could be sitting in any part of the world, but if you have the desire, intent to learn, you can connect with like-minded and kind of figure and solve these grand problems, and start a startup. And you said, one of the startups we started specifically for the prize. There is so much one could do, and I hope that more companies adopt these. I hope that more countries adopt this, because this is the only way to create an open platform and accelerate innovation. And I guess, like I said earlier, technology will play a huge role in creating the next step of evolution. You have also been invested in building a reinforcement learning framework for wildfires. Would you like to talk a little bit about that?
The way that we formulated it was we're going to simulate a forest for a century time span, and we are going to figure out what we should do over the course of that century in response to wildfires. And while you generally always want to suppress a fire if it's a structure, if it's a building, or in a city and so forth, forests, it's not actually so clear. There's a lot of forests, particularly in the U.S., where more frequent more frequent low intensity burns are a lot better than just letting the fuel build up to the point that it explodes. It also fosters species diversity on the landscape and makes it so that it's a healthier ecosystem. And actually, there are some harvest plans if you're harvesting timber where it is actually good to have periodic fires go through as long as it's not damaging the merchantable timber. So it's a really complicated problem where a lot of different things to balance, a lot of what we call in the reinforcement learning community, a lot of different rewards or shaping functions, or there's a lot of different terms for it, but it's a very, very complicated space, both in rewards and in simulation. So I built a simulator. It simulated 100-year time spans of the forest in terms of growth, fire spread, weather. It's a very tangled beast that was also very computationally intensive. So it would take quite a long time to train our reinforcement learning models. In fact, the algorithm we wanted to run, if we had run it from start to finish, would take more than 1,000 years. Which was not what you want to hear when you're in a PhD program and you want to defend a PhD in a reasonable amount of time. So I ended up working on a lot of ways of speeding up those algorithms, ways of speeding up the simulation, and I really arrived at the end of the day at this system where instead of taking 1,000 years, I could optimize the policy inside the space of just a few minutes. And I used that to build what's called a visual analytic environment. So a system where you can really change the parameters of the system and re-optimize policies and look at how those policies actually shape the development of the world. And this is kind of very early in what's become quite in vogue in the AI machine learning communities of interpretable machine learning, explainable AI. And I felt very powerfully the need to develop explainable AI system because very often my firefighting recommender system is telling people like, yeah, don't fight that fire, let it go. And when you go to a firefighter and you tell them don't do your job, they don't like that. Even if they agree with you and like understand the trade-offs and everything, they want to know why. They want to check your notes. You're just someone that's been in a lab. They've been out there fighting the fires and they understand the way it actually works. And that's where developing this visual analytic environment was very important. Both so the people I was kind of selling the solution to would trust it, but also so that I would believe that I haven't done a terrible thing to millions of acres of land or something of that nature.
Lovely. Wish you the very best for it. And I'm sure this is you just scratching the surface. The more you kind of understand, there'll be like a better framework for it to kind of like be something which adds real world value. So you've also been part of Syntiant Energy, which has been building neural processors, and so before you talk about it, what does it do? Why do we need it? Why is it unique? Could you talk about Moore's law, because that seems to be slowing down at this point in time. So could you kind of like explain Moore's law and then get on to explain Moore's law in the way like how would it impact us and how would it impact the growth of technology?
Sure. So Moore's law is, I'm not going to give the exact statement of it, but it's basically the doubling of transistor density over every year and a half or so. Then there was a corollary attached onto it after the fact of, or like a halving of price for things as well. And we've been plugging along for decades at this point where Moore's law, who I think it was Gordon Moore at Intel that made this prediction, and I don't think he was meaning it to be as much of a rule as it became, but it was just really the way that you stayed ahead in semiconductors was to just put more and more transistors in a smaller and smaller area, and that's a very powerful thing for the speed of computation, because as you shorten the distances that those electrons are traveling and make the transistors smaller, you don't have to wait as long. Like if you can pack more in, you can do more. You can do more in parallel in some cases, and we found that it's getting more and more difficult to keep up with that. We kept pace with that for many decades, but the problem with saying that you're going to have something like clockwork eventually, we know that eventually Moore's law will break down. I think it's official at this point, but I believe there's still some debate over whether that's organizational failings or whatnot. And the problem is, once we get there, the chief engine in progress in computing has stopped. Like a lot of the assumptions over the things we should be working on stop being true. It doesn't make sense, for instance, to optimize a lot of our software systems, and especially our software systems for specific hardware, because if by the time you complete that, you have twice as fast of systems, you no longer need to do those same optimizations, or you should just shift to the new platform, and you're better off doing that. So we've had this long period of time where we haven't been investing in really good co-design and hardware and software, and I think we're now entering a period where it makes a lot more sense to think more complete stack. Think of the software that runs on the hardware, and what software is intended for the hardware that you're designing. And I think, are seeing a lot of leadership, in particular out of Apple, in this regard. Like, they took on silicon design in a big way that most hardware manufacturers do not do, at least not for the class of processors that they need. And they are already seeing to reap the benefits of that, because they are designing the operating system, they're designing all the software that runs the operating system, and they're bridging all that thought stuff of software down to the real gritty silicon that's designed. So this is where I think Syntiant enters in as well, where machine learning people like me, we have largely forgotten about electrical engineering as a field. We just decided we'll rely on Moore's law. We don't need to talk to them. They have weird units for things like hertz and all that. That just sounds painful. I don't want to deal with that unit. I'm going to deal with my loss functions and my back propagation. I have my own problems to deal with, and we'll just trust that it's going to run on the cloud, where it's going to run in this infinite power and energy and scalable cluster, where we're going to run it across 10,000 different GPU nodes, because I'm working for a major corporation that has a near infinite compute budget. A lot of the fundamental advances we need, because we are hitting into this wall of now we need to develop hardware that's better for the task, and not hardware that's better at doing everything. When you specialize hardware, you can make it more powerful for the task while making it less power consumptive. And I think Syntiant is pushing very hard on the other side of that equation of how do we make it as energy efficient as possible. And we found that you can get many orders of magnitude improvement of energy efficiencies just by saying this chip is going to compute a neural network. Like, that is its purpose. And all the electrons are going to be dedicated to computing the neural network. And that's where we started off about 4 years ago at this point, and produced our first mass market chip, and have shipped more than 10 million units at this point, which is incredible for something that just does neural networks. Like, neural networks are going out in the world in a much more real way.
Would you like to talk a little bit about the applications of these neural chips?
Sure. So neural networks are very, very good at processing what's called unstructured information, audio and video, images, sensor inputs. It's basically anything that if someone told you, describe, write a computer program that tells me whether something is a cat or a sailboat, and your job was to go to each of the color values and every way that a cat and a sailboat could present themselves. It's actually a really difficult thing. If you go back to early in the course of AI, there's some grad students that were assigned to solve this problem, I think in like the 60s or 70s or so. And they thought it would be practically the level of difficulty of a summer project, but it actually ended up taking like 30 or 40 years to solve it in a real way. And that's because hardware actually needed to catch up with, hardware and data needed to catch up with the problem. And so neural networks very good at processing things like images, and Syntiant is really carved out its like starting niche in audio signal processing. So detecting what words are in a continuous speech. So a neural network could be applied to what I'm saying right now and transcribing the whole thing. All those systems at this point are built on top of neural networks. And this is where there's a great opportunity for Syntiant in moving the processor from the cloud into things like cell phones and hearing aids and the like, that most of the unstructured world is out here. We don't really carry a data center with us. Like you can send or backhaul all your data up to the cloud and get a response back, but that's energy intensive, drains your battery very quickly, and it is also not great for privacy and related properties as well. So I'm quite eager to move as much as possible out of the cloud into our consumer electronic devices, where it's a thing you own that you get to dictate the terms of its run, rather than everything going to a mysterious place.
I've been invested in virtual reality, and I've been invested in it since 2016. And at that point of time, we built our own 16 camera rig. Google was building their array, which is like a Odyssey. It's a 12 camera rig. It's a stereoscopic camera. And we built a 16 camera rig. And at that point of time, everything was so difficult, stitching those video footage together, for the stereoscopic view. And everything was so cumbersome. And cut to like just 5 years, things have grown exponentially. We have these cameras which are cheaper. We have software which helps you edit and stuff like that. So what I'm trying to say is that technology is growing exponentially. Now, somehow we've been in the narrow space, when it comes to artificial intelligence. So there are these certain bunch of people who believe that, in another couple of decades or maybe the century, we might have machines that could have human level intelligence. Now, there is some really serious researchers, scientists, companies vested in the space like DeepMind, OpenAI, you name it, Rich Sutton, and some really, really, deep thinkers. What are your views on artificial general intelligence? Could you describe artificial general intelligence, and what would be the frameworks if we have to achieve AGI?
So artificial general intelligence is being close to what we actually think of as intelligence in people. It's able to independently learn. It's able to do more than originally taught. And this is where there's also people talking about potential like runaway, like it learns so fast that we can't recognize it within a day, because it just kind of bootstraps and builds off of itself. I think it's pretty clear that is possible, or at the very least, we have an example architecture in the world of general intelligence in the human brain. So conceivably, we should be able to create an artificial form of that if we're able to just create a clone, effectively, of the human brain in some form. So yes, I would argue it's possible. Um, the thing I think I want to emphasize though is while people say uh, they are working artificial general intelligence, one of two things is happening there. Either they are working on a component or an aspect of AGI that they see as important. So some element of reasoning that one believes to be linked to artificial general intelligence, or for the lack of a better word, and at this moment they are effectively a crackpot. Like you don't go straight to another solar system on the basis of your backyard tinkering. Like I won't say it's impossible. It could happen. They could have such a virtuous breakthrough that happens, but if the logic of the person that's taking the incremental approach is correct, and that they have to figure out how to solve that more limited problem, if you haven't been able to solve that more limited problem before the bigger one, then you're in bad shape. It's almost always better to get your bearings and to figure out what the elements are if you're trying to do before you go straight shooting out of the solar system. So yeah, did that cover all the elements for you there? Or?
Yeah, sort of. Yeah, so I'm going to linger on this subject a little bit more. So you mentioned cloning the human brain could be one of the route or path ahead. Now, I think back in early 2010, there was this connecting project where some engineers kind of scanned or mapped the entire cognitive structure of a C. elegans worm. C. elegans worm is somewhere around, I think, roughly around 302 odd neurons, and they kind of captured the entire data and they put it on a connectome, a digital platform, and it actually behaved exactly like its physical version. The digital copy was behaving exactly like that. So in theory, if we can do it with 302 odd neurons, we should be able to do with 80 billion and 100 billion synapses. Now, I know obviously there's like a huge, you rightfully pointed out, we're tinkering around the backyard to go into the next. It is maybe that's like kind of the metaphor for that, but somehow, my perspective, I don't think that it's impossible. If you feel the same, who, according to your peers, are asking the right questions or at least at the right path to building an artificial general intelligence system?
One argument I like that comes from Max Welling is that the energy efficiency of the human brain is so high as compared to our silicon computer realizations that if we were to try and scale up to the human brain, that we don't have enough energy, or at least it would be truly immense to make that happen. And this is where we haven't been thinking about power for so long, but the people I personally take most seriously are the ones that are figuring out how to really do a lot of the kind of supercomputer work, but in a way that is also energy efficient. Like you have to design the whole system end to end to be doing a neural computation, and there's a lot of people working on more kind of human computation styled way of doing things, where they're called like spiking neural networks or neuromorphic computation, that in-memory compute and the like, that it's getting a little bit closer to the way that humans compute things. And I don't mean that in the sense of like there's a bunch of meat in there doing the computation. I mean it in the sense that like mathematically, if you look at what the brain is doing, it's a bit closer to that. Like it's computing on continuous values instead of on these discrete binary values that we've built up all of our compute infrastructure on. So I think it's I think we're getting to the end of Moore's law. I think we are getting to really the next phase of opportunity in computing, that we can no longer rely on just shrinking these things down, and now we can think a little bit more about making strange and exotic forms of computation, and going back to like where we were in the 70s, where you had a lot of fighting over analog versus digital computation, where analog, it just sounds old and out of touch and everything, but it actually has a lot of useful properties when it comes to intelligence, and we just haven't figured out how to use those design principles in a way that is paired with our now modern understanding of how we can compute a neural network.
I feel that, if we come together, create collaboration, there will be acceleration in technology and these huge innovations, which you could figure out. So that's my point of view. So, there is obviously, all of these companies who are creating some great solutions and frameworks. Recent technological advancement, artificial intelligence being GPT-3, which can be text to code and so many other things. There's AlphaFold 2, which is kind of, they say they solved the protein folding problem. Then there's MuZero, where you don't need to give it, your rules, but it can play any game. So, as somebody who's been invested in AI, what's your views on these recent advancements?
I think they are very impressive engineering advancements. I feel somewhat kind of tortured by them as well, in the sense that a pitfall in AI that is many people have fallen into in the years has been that every time you solve a problem you formerly believed to be associated with general intelligence, you then redefine it so that it is no longer associated with that. So for instance, people said, if you solve chess, like, the smartest people know chess. Like chess is a really deep play game. And then people figured out how to do that fairly early in the development of AI. And it's really just kind of brute forcing the problem, like trying a bunch of different stuff. And there's some heuristics and other intelligence you put on top of it. But we look at that now and we're like, yeah, we've defined that to be AI, but it really isn't. It's not that. And I feel like with a lot of these modern systems that are trained on like the entire internet, like more spoken and written word than has ever been available to any computer before, that it seems like if we keep on scaling this, it might get harder and harder to distinguish it from general intelligence, and maybe that's all it takes. But I hope we're more than that. I hope that there's a little bit more than just throw an increasing mountain of data at it, and then it'll become more and more mysterious in the way it behaves and the things it can produce. And I hope that I'm not deluding myself when I look at that to say we're somehow special and that there is more to intelligence than that.
Or cognitive structure, or the physical universe. If you go deep down into everything we made out of atoms, now, yes, we know so little about it, both, even our universe and even our brain, and somehow both of them behave very similarly. I was having a conversation with Randall Coney, he was a neuroscientist earlier, and he's kind of working on whole brain emulation. And, there is so much little we know of it, But yes, things are opening up to a point where it's starting to get very, very exciting. And that excites me, that we are finally understanding. I mean, I cannot say finally understanding. We are understanding what both is, whether it's the outward universe or the inward universe. And both of this, if understood, can open up and completely transform mankind. And I'm excited for this space, and that's the reason I do this podcast, where I feel that human creativity, ingenuity is, infinite. I mean, we are possible for so much more, and we are just scratching the surface. And for the first time in human history, I don't know whether that's a right statement, I think the world has come together, and that is happening, I think, only and only because of technology. It has given us an opportunity for you, me, and the entire world to communicate and push at those things which you thought was impossible. We are kind of, now that the word impossible is being, pushed at. That's the reason I call my podcast Change I Am Possible, because I feel that there's nothing which is impossible unless you kind of like really keep on pushing at it. We can. I think we are the gods, because I mean, if you look inside, I mean, you said we are very special. Somehow I feel that we are not so special. I mean, because if we can, ourself, or body, a human body or biological self is made out of trillions of cells which functions because of electricity. Now, or brain, we've got 80 billion neurons and 100 trillion synapses. They function because of electricity. And so are we mechanical by nature or biological? That's this thing. So would you like to paint a future? Where does the world go in the next 10 years? Where would you see yourself in the next 10 years?
I think we need to continue exploring the duality of artificial intelligence, and minimize the bad and maximize the good. And there's tremendous risks and opportunities in both. And I'm hoping that we've made enough progress in AI as a research field at this point that we can now really start taking out of the hands of people like me that have been mostly just heads down on coding these things and training these models, and put it in the hands of people that know how to make the good in the world, and put it in the hands of the people that know how to ensure that that system, when it's in the world, is not doing bad. And we have this kind of almost priesthood sense towards AI at this point that I don't think is healthy, and that we need to get as many people that are that understand the development and safe application of these systems, and we'll be a lot better for it as we move from AI being something that sits up on a pedestal to something that is just laced through every other field of research and engineering. We're going to see a great flourishing of society, and it's on us to make sure that that's a correct statement. So next 10 years, I think it's going to be a ride. Good and bad things are going to happen. Change is rarely comfortable, but in the end, this is a worthy place for humanity to go to, and we can go there together.
Wow, what a profound note to end on. Change is inevitable, and you said minimize the bad, maximize the good. On that note, to my listeners, if you like what you see in here, please press the subscribe button. Until next time, see you guys. Thank you, Sean. Really appreciate this.